king, the emperor, probably the best person in the galaxy to talk about thermal networks, Jay Egg. And we'll get to Jay in a second, but I just wanted to thank you all for joining us for our monthly, sometimes more than monthly, webinar series, where we talk about what's happening in the building decarbonization space. For those of you that are new to the Building Decarbonization Coalition, we are a coalition of utilities, manufacturers of heating equipment, the design and construction community, government agencies, and nonprofits, all working to eliminate pollution from the built environment through both policy and market solutions. We have a fantastic membership program that if you're not a part of yet, please do consider. We have all sorts of events, wonderful white papers, a monthly newsletter, forums to talk about the policies that are happening in states and nationally, and even more benefits coming. And so if you're not yet a member of the BDC, please do check out our membership page and consider joining us so you can keep up on events like this and many more coming up. We work at the BDC really on 5 major barriers that we think are holding back the complete elimination of pollution from buildings. Number 1 is really awareness raising, making sure that policymakers, consumers, and the industry have a really clear perspective on building decarbonization and the benefits of it compared to continuing to rely upon fossil fuels to heat our lifestyles. Number 2, we need to make sure that customers are getting a good value proposition out of any of the building decarbonization policies that we are pushing. This includes capital costs and making sure that the technologies that we're promoting are going to be a comparable or cheaper cost than their fossil fuel alternatives, and making sure that we have good rate structures so that as we're making these switch, we're protecting consumers that are on the path of decarbonization with us. Number 3, we need to make sure that we're building an industry where businesses can run sustainably, where they can pay good wages and they can be profitable on the path towards this transition. And they're at least making as much, if not more, off of building decarbonization than they were off of installing fossil fuel equipment. Number 4, we need to be sending really clear messages to the supply chain. The entire supply chain needs to have a solid understanding from policymakers and from the building decarbonization community about the timelines upon which we are basing this transition and the changes that are coming so that they can start to change everything within their operations, so that they can start to change their manufacturing operations, so that they can start producing the products that we're going to need at the scale we need in the time that we need it. Critical to this also is getting barriers to the supply chain out of the way. Inadequate infrastructure in buildings, inadequate infrastructure in the ground, as we'll talk about today. We need to make sure that we're getting barriers to the supply chain out of the way. And lastly, policy alignment. We cannot have policies like our building code policies, our energy efficiency policies, our affordable housing policies out of alignment with our climate policies if we're to be able to hope to really meet the speed of this transition that we're trying to achieve. And so these are the major areas that we work on here at the coalition. And that first one, raising awareness, one of the things we do at the BDC to help raise awareness is really this webinar series. This webinar series is an opportunity for us to share with all of you some of the top thinkers, the top doers, the top designers, the leading lights within the building decarbonization community to come together with us and have a conversation about what's happening out there in the space and how we all can get engaged in it. And so I'm so excited to have Jay here to work with us. We have some fantastic webinars coming up. You know, everyone's talking about the Inflation Reduction Act, not your retirement program, but the Inflation Reduction Act. And we have one of the best speakers on this coming up on September 14th. Nate Kinsey from SEALD is going to be presenting about the Inflation Reduction Act and the implications for the building sector at our Lunch and Learn series. And so that is limited to members of the coalition. And then on October 13th, we're going to be having a very, very exciting session about the very first 120 volt heat pump retrofit ready heat pump water heater. 4 years of development, and Rheem is the first manufacturer to come to market with this. You'll be able to plug these units directly into your normal 110 outlet of the wall to be able to produce hot water. And Rheem's going to be unveiling this model on a webinar with us in about 1 month. So please go to our website and our upcoming events page to register for these webinars, and always let us know if there's a topic we haven't had a webinar on that you'd like to hear from. We'd be happy to consider hosting that as well. So just some logistics before I hand it over to Lisa. Everyone's muted on this. We had a bunch of registrants, and so we can't just have you willy-nilly doing your dishes in the background and interfering with the audio. So everyone's muted on this. Please stay muted. Please feel free to ask questions via chat, and we're going to save time at the end in order to be able to answer those questions. This webinar is being recorded, and it is accessible to anybody that is a member of the coalition that wants to get it. We have a member portal with just fantastic treasure trove of all sorts of building decarbonization stuff, including all of our webinars recorded. So if you would like to get a recording of this webinar, please do join us as a member, and you get so many other great member benefits as well. And so with that, I am going to hand it over to our wonderful New York director, Lisa Dix. And so I'm going to stop sharing and let her share, and I'll introduce her. Lisa came to us after really working with a strong coalition to develop the offshore wind industry in New York, and a strong history in working to end the production of coal-based electricity in New York as well. She is a fearless and fierce advocate for the environment in Albany and all reaches of New York. And we're so excited to have her on the team, and she's going to be introducing Jay and then engaging in a conversation with Jay moving forward. So thank you so much, Lisa, and thank you, Jay. Looking forward to a great webinar.
Hello, good afternoon, and to all the East Coasters, and good morning to the West Coasters and all the in between. I am so thrilled and honored to be here today with our esteemed guest, Jay Egg. For those who are just getting to know Jay is a global geothermal energy expert and has truly earned the labels of visionary and game changer in the adoption and the deployment of thermal energy exchange. Jay has been at this for over 35 years. He's a certified geothermal designer and a mechanical professional, and he is a very passionate thermal energy advocate. I had the distinct pleasure of getting to know Jay earlier this year in 2022, when a mutual colleague and friend of ours, John Murphy, who is the president of the International United Association of Pipe Fitters, Plumbers, Sprinkler Fitters, and Steam Fitters. I think I got all of them in there. Introduced us to really start having conversations about thermal energy networks. And the pipe trades had been talking to Jay for quite a long time, really trying to learn about thermal networks and thermal energy systems, and really wanted to start to have a conversation about how we could work together to do this in New York and to scale thermal energy networks in New York. And so as a result of those conversations that we had a vision that emerged, and we basically created an idea that we wanted to work together in this the last legislative session in New York on a bill, and writing and trying to see if we could get traction on a bill together to advance thermal energy networks at the utility scale. So we did that. And that's where the Thermal Energy Network and Jobs Act was born. BDC, with the help and leadership of John Murphy and the pipe trades, the Alliance for a Green Economy, Align, which is the Alliance for Greater New York, the New York AFL-CIO, the New York State Building and Construction Trades, the Utility Workers 1-2, New York League of Conservation Voters, the Sierra Club, and every utility in the state of New York pulled together and really came up with a concept for a bill. We also worked very closely with WEAC for environmental justice. And we ended up getting something that everybody agreed on and that we could really try to work together on in the legislative session. The long and short of the story is that it was a resounding success. It really took off in the legislature. And the reason why is because of the uniqueness of the coalition that we were able to create, and just the broad agreement that we were able to build in such a short period of time. The legislation passed unanimously in the New York Senate. It passed nearly unanimously in the New York State Assembly, 143-6. And much to all of our honor, we were able to join the governor of the state of New York, our fearless leader, Kathy Hochul, in signing the bill into law on July 5th. So the reason why this was such a resounding success, and Jay is going to get into this more when in his presentation, and we'll have a more conversation, is that what we really realized in these conversations together is that this is a true transition pathway at scale that every single leader that was part of this effort in New York agreed with on principle. The environmental leaders and climate justice leaders, they really saw all the benefits of scaling another tool in the toolbox to scale building decarbonization at a neighborhood level. The pipe trades and the building and construction trades and the New York AFL-CIO saw it as a huge job creator, a union job creator, that cut and spanned all across every trade in New York State. And they saw it as a pathway, a transition pathway at a utility scale. And the utilities also saw this as a transition pathway in terms of the questions that are going on right now with the climate law in New York is, how are we backing down the gas distribution system? And then what is the solution? And the utilities really saw this as a promising solution to be able to have an alternative and a key piece of a transition for the utility. So without further ado, I would love to introduce my colleague and my friend, Jay Egg. Jay is going to be giving about a 10 to 15 minute presentation on thermal networks, because we always have the question, what are thermal networks? How do they work? And Jay is going to try to help us answer some of those questions. Him and I are then just going to have a little bit of a back and forth of question and answer, and then we'll leave open the last 10, 15 minutes for questions from you all to Jay. So Jay, you want to take it away?
I sure do, Lisa. Thank you so much. This has been, I'm always so energized whenever I do anything with you. You make things happen, and I thank you and Panama and the whole team for pulling this together. I'm going to share my screen and give kind of a primer on these thermal energy networks. Many of you may have seen this because we were privileged to be asked by the New York City Council in about 2014 to explain to them how it would be possible to convert most of New York City's 1.1 million buildings to geothermal heating and cooling. somehow back even then, they recognized that geothermal heating and cooling had a real advantage, especially not only with decarbonizing, but managing the electric grid. And we'll talk a little bit more about that. So let's put a tack in that one. Let's talk about why we put this together for an explanation of a thermal energy network. First of all, a thermal energy network is a lot like a power line or a gas line, except it's filled with water that carry thermal energy or BTUs. And the reason why this is important is even in the middle of the winter time when it's below freezing outside, we have commercial buildings, factories, and facilities that are doing a lot of data and computer and robot work, whether it's commercial buildings or, like we said, factories or something, and they always have this extra heat because they create more heat than they need. And you can see that in the winter when the cooling towers on the roof are billowing steam because they're rejecting heat. The first and foremost genius of a thermal energy network is connecting all of the buildings in a network thermally, so that when commercial buildings and factories have extra energy, that can be pumped into the thermal energy pipeline, which is the best way to imagine it is it looks just like a city water or a fire main filled with water. And it is indeed just filled with water. And so this carries away the extra energy in these buildings. Meanwhile, in the middle of the winter, these apartments or single family homes are who have been spending hundreds of dollars a month for heating now can use this free energy that had been rejected through the cooling towers to help heat their domestic hot water and provide comfort heating. It can also be used for, everything from recreational facilities to any other heating and cooling needs. And that's the important thing, since this is a thermal energy network. It not only takes heat out of buildings and puts heat into buildings, it gives us the ability to tie in heat pumps throughout the entire network. One of the great examples, and I'll just share this one real quick. This is kind of a pocket example of a city zoo that has elephants and giraffes that need warmer climates at night versus a polar bear that needs a cooler climate. And so this polar bear exhibit has a heat pump that pumps heat out of the water, and that heat then gets pumped into the radiant floor for the elephants and giraffes and so forth. In a bigger scheme, we can do this here, and we can actually extract and exchange heat with the subways, the wastewater systems, the structural piles that go on buildings, the surface water, such as the Hudson or any surface water bodies, fixed lake or anything like that. And that's the beauty of it. So where I really have to give kudos to Lisa and Jessica, Ajale, and everybody on the whole team, the ladies at HEAT, which is the home energy efficiency team, and that would be Audrey Schulman and Zainab Magavi. They all got together and put together a one-pager that explains to the public what thermal energy networks are. And I would love to read this whole thing to you, but you can get these, a handout, a single pager, right off of their website when you go on to the Alliance for a Green Economy, Heat Smart Tompkins. And they have it's just a great way to explain it. Where I really began to know that this was starting to take off was not only what was going on in Massachusetts, and earlier this year when Christy Egg and I had on February 15th, we went with several of the business managers of the UA locals in New York. We toured a large central energy plant in Manhattan, and we went to Long Island and toured a university campus, all of which were being converted with the help of NYSERDA and other public funds to thermal energy networks. While we were doing that, I was amazed, first of all, that we had the interest of the of the unions. And here's the reason why. As we're decarbonizing our buildings and so forth, all that a lot of people see is that the boilers and the furnaces are going to be turned to some type of electric devices like electric heat pumps. What they realized when they looked through this thermal energy network idea was that not only is the thermal energy network a solution to not having to drill holes everywhere, but it's also a pipe solution, which is going to require a lot of skilled labor to put these pipes in the ground. When you think about these pipes in the ground, it's important to remember people, the first thing they say, the naysayers, the first thing they say is, oh my goodness, do you realize how much infrastructure that takes? Well, we've been through it many times before. And in case you don't know it, before the 1950s, there really wasn't any piped infrastructure for natural gas. But during the Second World War, we had to pipe a lot of oil from Texas to New York. And we realized that we could pipe natural gas. So during the 50s and 60s, 2.5 million miles of natural gas infrastructure was put in the ground. We can do that again. And here's the beauty. That infrastructure can follow the same pipelines we already have in the ground. And it's so fun to look at this kind of graphic chart and see that a thermal energy network is very similar to a natural gas network. Both of these infrastructures require pipe in the ground. Both of them have a utilization technology that looks somewhat similar. It's just that with natural gas, it's a furnace or boiler at 95% efficiency at the very best. Or with a geothermal energy network, it's a heat pump that has 300% efficiency or better, even to 500 or more percent. And a geothermal energy network provides both heating and cooling. And what have we learned recently from climate change? Air conditioning is almost as important for health and human safety as heat is, because it's treacherous out there. And we're in the middle of the summer and we realize that. So we get from the same pipeline, we get both heating and cooling with a thermal energy network, or with natural gas, typically you only get space heating and domestic hot water. The difference is in the energy input. The energy input is all of these things you see here: surface water, wastewater, existing infrastructure. There is never a situation where you have to burn something like natural gas. You can, but you don't have to. The difference is it can all be gained from thermal energy infrastructure or from burning hydrogen or some other more clean fuel. So we have an energy input that's earth exchange. And when we do that, we end up with a whole city-based infrastructure that's taking advantage of the waste heat from the data centers and the commercial buildings, and that can be absorbed by the apartment buildings and so forth. And we can end up with a fully integrated network sharing energy. And when you look at the energy efficiency of a thermal energy network, it's just like a synergy. And we all know what synergy means. Two people coming together create with a great idea can create more, produce more work than the two of them separately. And that's the synergy of these buildings. Putting more buildings together, we can get, instead of 3 or 4 or 500% efficiency, we can get 900 or 1,000. Practically, you can never quite get to perpetual motion on this, but very close. We get to the point where we're just moving energy around much of the time. And it's a beautiful thing. So instead of wasted heat, like I talked about, with all this heat going out the cooling towers out of our commercial buildings, and not tapping into some of the other infrastructure resources that we have, we can do a recycled heat thing here, where we can take all the energy from extra energy from the data centers, the universities, the factories, the wastewater, and we can use that in our residential and places for domestic hot water and comfort heating in the wintertime. And we can reject all of that heat to surface water or down into the ground or wherever we want to during the summer months. When you look at the heat pump, the types of heat pumps, it's important to realize air source heat pumps are such a friend to the industry as are geothermal heat pumps. The main difference between the two of them is a geothermal heat pump is coupled with the earth or with a thermal energy network, where an air source heat pump is coupled with the outdoor air. Whether you're exchanging heat with the outdoor air or the earth, the same fact holds true. It is renewable energy. The outside air is going to get all mixed up with the atmosphere. Whether you're rejecting heat to it or pulling heat from it, it's renewable. It's recharged by solar energy. And the same thing is true with the earth. It's a massive, massive heat source and heat sink. So when you look at these in this illustration, and then you look at them in real life, it makes more sense. This is a split air source heat pump system right here that uses an air handler inside the space and a condenser outside, where in a building with a geothermal heat pump, they use a unitary heat pump that has both the compressor section and the air handling section all in one. And so when you look at it side by side, it's just this. Either you're exchanging heat with the outdoor air or you're exchanging heat with the ground. And that's really all there is to it. Then when you let a couple of engineers get involved, that's when you have to watch out. That's when it gets wonky, because we do things like this that really work, by the way. We say, wait a minute. Okay, we have a heat pump that can use any source now because it's now water source. Can we use solar thermal arrays to recharge it? Sure you can. Can you use wastewater to recharge it? Yes, you can. No matter if it's 0 degrees or 40 degrees or 100 degrees outside, guess what? With wastewater, it's always about 70 to 80 degrees. And so it's a great heat source and heat sink year round. So whether we're heating our building or chilling our building, we can use all of these hybrid variations to make things happen. So as we look at this in practice, it gets really big. And that's what's cool. Just as with Stanford and Ball State University and many, many other thermal energy networks that have been installed over the last 50 years, we can go in while we're redoing existing infrastructure. And this image bottom right is from West Union, Iowa. More than 10 years ago, or almost 10 years, I think it is 10 years now, they decided at the same time they were doing new city water mains to do a thermal energy network in their city. This is images also of Stanford, and these are taps off of a thermal energy network. And guess what? These two taps off of this 24-inch line that are 10 inches each, they can do an entire high rise rated at about 300 tons just by tapping in there, and they can exchange energy. So no matter what type of a rework you're doing, it works. And the funny thing is that in 1958, while we were building our natural gas pipeline, the National Electric Manufacturers Association got together and they pulled in a spokesman of all things, Ronald Reagan, and they started promoting all electric living because they said it was healthier. Well, you know, the natural gas line still went in, but I just love these medallions they came out with to give awards, and you put them on the outside doorposts, and it said total electric gold medallion home. And that's what we're coming back to. We're doing something the same way. And here is where you get to do a side-by-side comparison. As I said, air source heat pumps and geothermal heat pumps are both essential parts of our all-electric decarbonization revolution. But it's important to know the limitations and why governments are invested in air source heat pumps and geothermal heat pumps. And here's why. When in 2010, ASHRA headquarters, which is one of the governing bodies of the air conditioning and heating industries, arguably the largest, they decided on the first floor of their building during a retrofit to do all air source heat pumps. And on the second floor, they did all geothermal heat pumps. And corrected by square footage and kilowatts, they did this analysis. of their facilities. And what you see here is important, not to say one is better than the other. That's not what we're here for. We're here to talk about what the reality is of these things. Sure, it's more expensive to do a geothermal system, but what they do is they reduce your peak energy consumption and they reduce your energy bills. And you hear a lot of screaming in the industry about electrification because it will ruin, the naysayers say it will ruin the electric grid profile. And if it is all air source and you're doing it in super cold climates, even Atlanta saw these huge spikes in January and February and March and December for wintertime. Why would that be? It's really simple. It's not even a fair comparison. If it's below freezing outside and it's 60 degrees down in the ground, which heat pump has the advantage? Well, of course, the geothermal heat pump does. And that's why in certain places we need geothermal heat pumps. And you can see in this example, their summer peak for June, July, and August is, the winter peak doesn't even approach the summer peak. What does that tell you? It tells you that the screaming and crying we hear about ruining the electric grid if we go all electric is not going to be the case if we have a good mix of geothermal heat pumps, and that is afforded using thermal energy networks. Over and over again, in comparison side by side, geothermal heat pumps compared to air source heat pumps are going to perform better because they're coupled to the ground. You just can't put a geothermal heat pump everywhere yet. The magic of how this is done is when you're electrifying a building, 1 kilowatt through an electric space heater is going to give you 3,412 BTUs of heat. But 1 kilowatt through a geothermal heat pump is going to give you 17,000 BTUs of heat. And that's because a heat pump uses that 1 kilowatt to run a pump, a heat pump that takes that energy, takes that 1 kilowatt of energy and pumps 4 more kilowatts out of the ground to give you that 17,000 BTUs. Is it getting more clear how we can electrify the grid, electrify our buildings, and not ruin the grid? I'm going to show one more thing just to show that somebody has done a side-by-side comparison on this. This is just one of many, but I love this bar graph because HRAI, which is in Ontario, it actually covers all of Canada. It's their ASHRA, so to speak. In Canada, they hired Dunsky to do a performance evaluation of if they shut off all their natural gas and invested in their Ontario consumer infrastructure to say, we will help everybody either go with all air source heat pumps or geothermal heat pumps. They realized in this study that it would cost $435 billion to help all Ontario go to air source, or $572 billion to help all Ontario go to geothermal. They realized when they carried it out over 30 years that there would be electric savings for their consumers. That was a plus, but here's where the real plus is. The power generation and transmission costs decreased as geothermal heat pumps helped to reduce peak load impacts, saving Ontario infrastructure $494 billion, $500 billion in Ontario. And Ontario doesn't even have the population, I think, I haven't checked lately, of New York City proper. So it's about 15, 17 million, something like that. I'm probably completely wrong because I'm not really good at that. But with that, you know, I've shared as much as I think I want to share because I want to give Lisa some time to have a little back and forth with me. So Lisa, if it's all right, I'll unshare my screen.
Sounds good, Jay.
All right, going to unshare. You gotta figure out how to do it now. I feel like I'm getting so new share. It says, it's funny, I usually see my share button, but I don't see it. There it is, stop share. Got it. Took me a minute.
Awesome. All right. Well, I have, I was like monitoring the chat a little bit, while you were speaking. And, I wanted to bring a couple of questions that are, very similar. Some of the, there's a couple, the one that I really wanted to start with is this basic question of feasibility. So, there's a lot of naysayers that say, look, the thermal network, the thermal energy network systems are not tested. We're not tested at scale. And, I wanted you to just kind of, because you have been working for so many years globally on thermal energy networks, I kind of wanted you to just give everyone a flavor of where, like, how, just where these systems are, and just talk a little bit about the feasibility at scale. Like, is this being done? Is this brand new? Just talk to us a little bit about that.
You bet. First of all, it's something that's not really publicized because the communities and the cities and countries that have adopted this in Europe, for example, and even domestically, haven't made a big deal about it because there's not a lot to see. We had some of the same naysaying going on when we started with the natural gas rollout. It's like, how are you going to get this to all the buildings? It's pretty much the same infrastructure as doing a natural gas rollout. Not every engineering question was resolved, especially in retrofit situations. But suffice it to say, I think that one of the best and most comforting things to note is that Stockholm, Sweden has been on a thermal energy network exactly like we're talking about since the 1980s. And their infrastructure ties in with wastewater, surface water, ties all the buildings together thermally, ties their aqueducts and their subways and their transportation together in such a way that we have been able to not only study that, but we have on our staff engineers that have used this for their master's and doctoral theses because they've been in these countries and studied these. So what we're bringing to the US is like old hat to our professional staff. They're like, oh, hey, we get to do this in the US now, cool. And so it is not that new of a thing to do it. And for anybody that might say, oh, it's going to cost too much, I would go back to the Ontario study, which they're just not so pretty yet. There are also domestic studies that show how this rollout will save us on electrical infrastructure, because we will have to spend trillions of dollars to be able to handle the peak load in the wintertime if it were all air source, because it can get really cold outside. Think of the winter before last in Texas, where we knew that they hit that whiteout, blinding blizzard conditions for too long, and they almost crashed their electric grid, because no matter how good your heat pump is, if it's an air source heat pump, it's going to need electric backup more than it's normally rated for in the wintertime. So in order to solve that, we need to have these thermal energy networks. We can either put $1 in thermal energy networks as a society, or we can put much more, 3 or 4 or even 10 times more into our electric infrastructure. And that's where the sense comes in, the monetary sense. There is an ROI and there is a payback on it, and it's much better than the alternative.
Thank you. And it seems like there is also the avoided costs of continually, basically repairing existing gas infrastructure, right? Pipeline infrastructure, and building new.
Yes.
Yeah. And, there is some cost, conversation going on in the chat. Like, this is going to be so unbelievably expensive. And, I think like your answer then is, look, there's going to be a lot of avoided costs in both electric system upgrades gas distribution system upgrades, and all the avoided costs of building new gas and maintaining new gas pipelines.
And it's already been proven in Massachusetts. The gas company Eversource had a $9 billion ask to fix some leaks and so forth. And that's when HEAT, the home energy efficiency team, got involved and said, hey, let's use that $9 billion to start building out a thermal energy network, because we're putting money into something that's going to be outlawed soon with decarbonization. If we do it this way, we're going the right direction. So they're doing pilots there to prove it out too. And if we had more time, I know you could do it as easily as I could, Lisa, we could talk about exactly how they're doing that. But we have a lot right now. If you go in New York, there are dozens of community heat pump approved projects going on, being built and being engineered, and the same thing in Massachusetts. And we have a template already, as I said. We have lots of examples. We're not fording new territory now. We're just improving on old territory.
Yeah, and it also, in building off that, it seems like, part of, the idea about, the legislation, the Thermal Energy Network and Jobs Act, one of the big ideas was that, one, it's a really good idea to test and pilot this, right?
Yeah.
So that we really can understand how we can, create those rates, rate base it, and how we're doing this at a neighborhood scale. Like, there's a lot of questions that still need to get answered in front of the New York Public Service Commission. But can you explain, or can you at least talk about just a little bit, the rationale for why it was so important to do this at the utility scale, and why utilities in particular have some advantages in terms of rights of way and other things that are really going to help defray costs. They have the labor force and other kinds of advantages of having utilities be able to own and operate these systems.
You ask such a marvelous question, and I'm going to start about 2 weeks ago when we were getting ready to fly to Reno, because the biggest conference in the US was taking place last week in Reno. And I got a call or an email from Con Ed, and Con Ed said, we're sending 2 engineers to Reno to go to your all-day thermal energy networks workshop on Saturday, a week ago Saturday. And I was blown away. I didn't even know they had a division yet. So what the Thermal Energy Networks and Jobs Act did is Con Ed Legal got notification from their lawyers, learn about this and do the pilot. So they flew 2 engineers out there, and they came back. And yesterday we had a 3-hour conversation with that team on what Con Ed's part is on it. And we put up on the screen the Penn South cooperative apartment complex, which is right in the middle of the Chelsea district of Manhattan, and it's 15 22-story buildings. And we said, this is why we need you, Con Ed, because we have a 4 megawatt thermal load for these 15 22-story buildings. We don't want to come in and drill 100,000 holes, and I'm exaggerating, in the middle of Penn South, when right across the street, the US Postal Service has their sorting station for Manhattan, and it puts off 8 megawatts of thermal energy through its cooling towers all year long, even in the dead of winter. We said, we want you, Con Ed, to pipe that energy over to Penn South, and then we can turn off their boilers. Just by using the resources we have and a utility to pipe it from one place to the other, we have solved a major decarbonization issue without drilling a single hole. And that's just the beginning.
Thank you. And finally, I want to give everyone a chance to, a few questions to emerge from the folks that are listening. One of the burning questions that always gets asked is like, what is a thermal energy network? Which I thought you did an amazing job. But really, what are the distinctions between, I think some people are very familiar with like district energy systems or district heat. So can you just give a quick high level? What are the major differences between thermal energy networks and district heating or district energy heating systems?
I love that. And I'm so glad you asked. What you'll hear about, there are 5 generations and probably more someday, but there are 5 generations of thermal energy. And I'm just going to mention the 4th generation would be distributed hot water and distributed chilled water, where you can use it without any type of real equipment, just a blower in the buildings. We are talking about 5th generation, which is distributed ambient temperature water. Now, what does ambient temperature mean? That generally means the temperature of the ground. So in New York, it's 55 degrees Fahrenheit. Now, the cool thing about it is there's a huge bandwidth of forgiveness on that to share energy between buildings. And so whether the thermal energy network is at 40 degrees or 95 degrees, the heat pumps in every single building will be able to pull heat from that and reject heat from that, because every manufacturer makes a water source geothermal heat pump. Carrier, Trane, York, Rheem, Root, you name it, they all make water source. So all they do is connect whatever brand of heat pump. Instead of an air source heat pump, they connect their geothermal heat pump to the thermal energy network, and either they're pulling energy from it or giving it back. And then it's the utilities problem to figure out whether they want to extract more heat from the surface water, the subways, the wastewater, whatever. And then they either put heat into that thermal energy out of it, and they keep it balanced. It's just a little balance, and it's works perfectly.
One of the questions that I get a lot too is, how does the cooling side work to that? So you just talked about the heat side, but can you just give a quick high level about, okay, so then how does this cool?
Oh, this is a great one. My favorite analogy of that is my refrigerator. In the middle of the night, when I walk out to my refrigerator with my bare feet, I can open it, and it's how cool inside of it. It's 40 degrees if you open the refrigerator. The freezer is going to be 5 degrees. How does it do that? With a heat pump. Your refrigerator is a heat pump. Now put your feet by the bottom of that refrigerator, and what do you feel being pumped out? Heat. It's probably 100 degrees, a nice warm, it feels so good on my feet. It's a nice warm 100 degrees in a thermal energy network. Our houses one day, even our refrigerators will be connected to it with like ice maker pipes, and we'll be pumping that heat into the thermal energy network. Isn't that cool? And so our heat, our water heaters, our refrigerators, everything will be all tied to it. And so that's how an air conditioner part works, just like a refrigerator. Whether you want your house at 70 degrees or 40 degrees, tie it into your thermal energy network.
All right, thank you, Jay. And then Friday, did you want to like pick some of the questions that have been in the chat?
Yeah, actually, I think Jay, you and Lisa have been answering most of them. I will just add my own flair to say, like, yeah, that is so cool. I want my refrigerator to add to the network. There is one line of questioning, though, that I think really, when trying to wrap your head around all these different sources for heating and cooling or for the network, can you talk a little bit about, like, if you're using wastewater or some of these other kind of dirty kind of inputs, is there anything that needs to happen to either clean them up or to manage that network, like from a pH perspective or something like that? Is there any, can you talk a little bit about that?
Absolutely. We have a NYSERDA Flex Tech award that we're working on for one of the high rises in New York, and it's doing exactly that. So what happens is we tie into the wastewater main for the building, and there's a special piece of equipment the most common one is a shark, and it's a heat pump that has two separate parts. It's got an exchanger to extract heat out of the wastewater as it passes by, and we really don't know have to know how it does that, because then it just gets gross, but it does. And then we have a double wall exchanger, an NSF exchanger that extracts the heat. It runs through the Carnot refrigeration system, and out of the other side comes 145-degree domestic hot water. And we don't have to know necessarily a lot more about it any more than we have to know how we can get on Zoom on our iPhone, and all of that works. It strips the heat out of the wastewater, so it comes in at 70 or 80 degrees, and it pumps it back down into the sewer at 40 or 50 degrees, and all that heat's been taken out of that and put back into our domestic hot water system. It's like magic, and it's engineering wise, it's perfectly sound. It's been done for 20 years at district scale. Now we're just doing it at building scale. Isn't that cool?
It is. I have a question that it doesn't seem as, maybe I missed it. I tried to hurry and skim the chat. But can you talk a little bit, Jay, about the workforce? I mean, this is the question that everyone asks. It's the question that is getting, the New York State building and construction trades so excited, because they really see a vision for themselves. I also heard that Cornell has a system, a thermal network system, where, there were a lot of union jobs created just to build the system. But then, one of the questions is, what happens with the operation and maintenance of that system? And I had heard that from the pipe trades that it's 30 to 35 full-time union workers to maintain that system, which, just for a reference for the electric sector people, that is about the same amount of union employees in a gas plant, a combined cycle gas plant.
It is. And here's, I think, and I wasn't going to share this, but I'm going to, because on February 15th, here it comes. This is what we had. This is John Murphy, the John Murphy who makes magic happen. We're at the NYSERDA high rise in downtown Manhattan on February 15th of this year. And these are all business managers from the union. They were stoked because they went through the energy plant. This is the energy plant at Penn South, and realized all the piping that needs to be done. And they were just absolutely amazed. We spent the entire day together talking about that. And the reason why they're so excited is just like you talked about with, and I'm going to grab the image of, it's just going to take me a second if I can talk and chew gum at the same time. At Cornell, oh my goodness, we had such a wonderful, we're doing so much good work there. This is the Cornell campus. And this is just, I think this is one of the perfect diagram to show there's no limit to these pipe systems. Did you know at Cornell, they are able to, on Lake Cayuga, one of the Finger Lakes, they tie in, and without even running a chiller or a compressor, it's so cold in the lake, they cool the entire campus just with exchange. That's why piping is so important. And it takes hundreds and hundreds of union jobs to do this. And just as you said, Lisa, we are cooling with lake water, but we're heating with we're going to be heating with a new 5 kilometer or a 10,000 foot deep well they just drilled there that will provide heating, what we call deep direct use heating. So there are so many things going on that are going to keep our unions, our nation's pipe fitters going. This is what HEAT did. I really, really want to share this, so bear with me. HEAT did a study, and it showed how that they can use the existing right-of-way just like where the natural gas is already, and they can use the same pipe fitters and need even more of them, and just retrain them over to connecting geothermal pipe. to the buildings. Why is there more work? Because not only do they have to connect to the domestic hot water and the furnace, but they also have to connect the air conditioner. And eventually, like we said, it's going to be the refrigerators and everything that creates and removes heat in the building. So thank you for asking that. I get so excited about that because not only is it more jobs, it's a lot more jobs for a lot longer time.
Great, thank you.
You're welcome.
And I wanted to just see, Friday, are there any more burning questions in the chat that I may have missed? I want to make sure everybody gets their questions out there.
There is a great chat going on. Lots of people talking and answering each other's questions, which I think is fantastic. But there is one question that has come up a couple of times. The idea that this thermal energy network has to be piped to each individual's apartment or each individual's house, and there's just a little bit of confusion there. Do you think you could explain a little bit more about how maybe we already have the system to connect into this network, or do we have to really build it much more extensively to each person's home or each person's apartment?
That's a really good question. It's literally like this. If it'd be like us getting a new fiber optic network, we don't have to connect into it, but we can. So what we end up with is what looks like a water box in the front of our yard. And if we decide we want to put in a geothermal heat pump and take advantage of the huge rebates and everything, we do that. The electric company or the energy company comes out, and two pipes, just like sprinkler pipes, they're 2 3/4-inch lines. They run it right up, stub it right into your unit, and you're done. You have your air conditioning and heating for the rest of your life. It's so simple, it's not even funny.
So there's no water pipes that are going all the way through your house.
Nope, don't need that. When you think about water pipes and so forth, sure, in a great big apartment complex, they have chilled water and hot water and steam pipes running all over. That's our problem. We're changing those or using the existing and just running, it's just water through it. So a lot of times we use the existing. If they need new ones, we put new ones in. Big deal. I mean, it's got to happen. If they don't have them right now, if they do, which many do, then it's just a quick change out.
Yeah, and just really quickly, like at a neighborhood level, Jay, is there like a competition with space with all the infrastructure that already exists, say the water pipes and the gas pipes?
There really is not, because we're writing right now. One of my jobs is as a code official. So we are writing right now the 2024 Uniform Mechanical Code, the Thermal Energy Network section, working with the UA and so forth. And the nice thing is it can literally touch the water line. To say it takes no more space is almost, it's not quite, because you have the cross section, but there's plenty of room and there's no setbacks that will be needed. It's just, the pipes can't literally touch, but they can be so close together that that there's no spacing needed. So there's no infrastructure problem at all.
Great. Well, I think that we are at the 2 o'clock mark. I want to really just thank Jay for coming here and talking to us, sharing his expertise. I'm sure that there are going to be so many more discussions. In terms of New York, this issue is front and center. We're going to start seeing some of the pilots that were authorized under the Utility Thermal Network and Jobs Act begin to start moving forward. We've got a 2-year process in New York to really figure out how to do this at scale, and figure out all of the other kinds of questions. So it's a really wonderful process that will be ongoing in New York. So please stay tuned. And I really hope Panama saying in the chat that there's also 15 coalitions across the nation that are starting to work on thermal energy networks as well. So this is going to be an amazing emerging topic and a real tool in the toolbox as we start to think of our policy pathways in terms of scaling building decarbonization. So with that, I thank all of you, all of your questions, all of your engagement. And I thank Jay for taking the time today to be here with us.
Thank you. It's my pleasure. Anytime. See you soon.
All right.
Bye.
Bye, everybody. Have a great day.
Thank you.